Howdy, everybody. Welcome to Container Days. And today we're going to talk about how to build, deploy, and maintain distributed modern platforms using the best of GitOps and open source software. My name's Eddie Wassef. I'm the chief architect of Vonage. I'm based out of Dallas, Texas. I started my career doing .NET development and haven't stopped since. Do a lot of work with Kubernetes, a lot of work with containers, orchestration, operator work, and so on. And I feel that there's really a great synergy and great marriage there between .NET and Kubernetes. I do dabble a little bit in fishing. That is my primary hobby, and actually, it's not true. It's not dabbling. It's a habit. An addiction, and I actually have this job so I can keep fishing and pay for all the new cool toys that they keep releasing every few weeks. My contact information is right here on the board. Please do reach out. We're very active in the open source community. We love to talk about technology. We love to experiment and invent new things. So find me on LinkedIn, follow me on Twitter, or send me an email or star any of my registries. I think it'll be, I'd love to have that conversation and expand on a little bit of what we're going to talk about today. So today we're really going to talk about DevOps and how DevOps can help your deployment and your reliability and your cloud journey in general. We're also going to talk a little bit about GitOps too, and what that means. And while we're at it, some GitSecOps, maybe some SRE, a little bit of architecture as well. And why not? Let's talk about the software development lifecycle. All of these things relate to each other, and they really are important to understand the differences and the benefits for each of them. And how they can help you in your day-to-day, and how you can start building more robust and reliable software. So, what is DevOps? People have used the term, and some people say we're DevOps. We do SRE instead, which is I've always thought about it as the Netflix and Google models. But what is the difference? And can you have both? Or do you need to have one or the other? And some folks are really adamant that there can only be one. You're either a DevOps, you have DevOps engineers, or you have SREs. I don't necessarily believe in that. I believe, why not both? Why not have both DevOps and SRE? But then you really have to define what is DevOps and what is SRE. And the idea came to me. It really became clear, actually, to me. Back in 2019, there was a build conference where they introduced a couple of CNCF projects and concepts out there. One of them was Dapper, and the other one was called Rudder, which later evolved into the Open Application Model, OAM, and Kubevela for Kubernetes in particular. And they defined three roles. And they defined application developers, application operators, and infrastructure operators. And the important delineation between those three is that the developers, they define and build their application and components. And this is part of the spec. The V1 of the OEM spec says, this is what an application developer does. This is how they define it. Well, their application operator is the person who defines the instances of those components, assigns them to configurations. So, you're building, the application developer builds the app, but the application operator says I need to have three. They need to be this far away from each other. They need to have this much memory, this much CPU. And we need to expose it. We need to have a gateway for it. So they designate the operational capabilities. Then there's the infrastructure operator. And those are the ones that take the combination of the first two and actually put it on an implementation. And the whole point of this, you have to remember, is OEM is infrastructure agnostic. And so in this case, the infrastructure operator will take that and say, okay, well, you want three instances running in this type of container, running on this in this cloud. So I'm going to put it, on Kubernetes in Azure, or I'm going to put it in GKE in Google. I'm also going to use an Nginx ingress, and I'm going to use Calico CNI, or any of these other services that help enable the application to work. As we see here, there's three distinct roles, not necessarily three distinct players, but three distinct roles. And if you think about it, even in your open source contribution days or your own projects, you may have worn these hats at different phases of the project throughout the life cycle of it. Maybe you're building it, then you start defining how it needs to look, and you can build a Helm chart, or you can build, an OEM spec. But then you go to the cloud and you're either clicking around or you're writing automation to create something so that you can have that deployment. Some companies or some teams might have distinct roles. Somebody might be an application developer and operator at the same time, and then there's a separate team that does infrastructure. And to me, that started lining up to some very specific roles in my experience and in our company. So the application developer is a developer. That's kind of their role. We've been calling them developers. It's pretty easy for that. But the application operator, that's where the site reliability engineering comes from. They're the ones who look and understand the application. They're closer to the application and its needs, and they define what it takes to make it reliable. And they define what it takes to make it resilient. And they define how much resources it needs, how it should be rolled out, and all of this. And so that's where an SRE engineer, if that's redundant, and an SRE can go and really contribute. And then finally, from an infrastructure operator perspective, those are my DevOps engineers. Those are the ones that are evaluating technologies and either looking at and deciding, what's best for this organization or for this requirement. They're setting it up. They're creating the tools. They're creating the monitoring and logging stack. They're the ones that are deploying the clusters, choosing the ingress, choosing the CNI, choosing the storage classes, and providing a service so that the developer and SRE can easily deploy their applications onto that infrastructure. And so in my mind, you can have SREs and DevOps engineers side by side because each of them play a very distinct role. So what is DevOps really? We still haven't defined what it is, and we've seen this infinity symbol. But really what the idea behind DevOps is, it's a continuous cycle of improvement, of design, of deployment, of operation, and you want to get things across this loop as quickly as possible. There's a lot of different aspects between the sides of the loops. You see there's deploy. You can deploy in many different types of infrastructure. You operate and you have different monitoring and tools and whatnot. There's always continuous feedback, right? Whether that's going through Slack or that's going through email or through Ops Genie or something else. And then you go back and you start planning the next release based on the feedback that you got, whether it's good or bad. And then you build it and then you deploy it. And so the difference between this and what a traditional waterfall model is that you don't necessarily have a start and an end. It's a continuous loop. And the reason it's not a circle, I think, is because there is a very big overlap between continuous feedback and integration. And in my mind, that's where DevOps engineers really are interacting and handing over to SREs and to developers in that overlap. So it makes a lot of sense to me to have this as an infinity symbol versus a circle. And hopefully you understand that it's a concept, not necessarily a process that's well defined. It's really, how are you going to take this loop and start continuously improving and integrating and releasing? So why is that important, right? Why is DevOps important for your system? Why do you want to have this loop as tight and as quick as possible? Well, the first thing is your software return on investment starts when you get to production, right? It is not when you are done coding. It is not when you close the ticket. It is not when you commit the code. It is only when it gets to production. And so when you traverse from the left side of that infinity symbol all the way to the right, and it gets out there and your customer starts seeing it, that's when the return on investment starts. And so obviously you want that cycle to be smaller, right? Even if it's not the full gamut of the release, You want to get things out there, small investments. You get, if you lose it, it's a small loss. If you win, it's a small incremental gain, but you go through that loop very quickly. And so the more you can reduce that cycle for return on investment, the better your software is going to be. And the easier time you're going to have to improve your software and to get out of technical debt, and even maybe not even take any technical debt. So that's one of the first things that DevOps helps with. The next thing is a very interesting study that was conducted by a company called Garden.io on the amount of time that teams spend not writing code. Now think about this: 15 hours every week teams are spending without writing code. That's $60 billion a year in the US, wasted on things that are unnecessarily required, but they don't give you value to your application. So think about it this way. Waiting for builds is part of that 15 hours. Provisioning environments, waiting, waiting for tests to run. All these other things are not part of the value that your application code is delivering to your customer. And that's a lot of time. So imagine being able to get that time back, right? That's a tremendous amount of time. That's almost 2 days, a week. It's a significant portion. And so having the tools and having the integration and the standards that are provided by DevOps will really help you reduce that 15 hours down, so that you don't have to build pipelines. You don't have to wait for a build to finish. You don't have to wait for tests to run. You don't have to reinvent the framework. You don't have to add all of the data access layers and plumbing and all of this stuff. You can really just focus on your code. And that's ultimately comes down to 50% of the software development lifecycle is context, not core. And let me explain what the difference is between context and core. Think about why your software is special. What are you giving your customer that's different than your competitors? That's your core, right? This is what makes your software special. It's what you're offering as a value add. Context is everything else, right? You don't necessarily sell your software because you can send email real well, right, for notification. You're not selling your software because it has a great CI/CD pipeline. You're not selling your software because it has a great, caching layer that interfaces with Redis. This is all context. And as software developers, we understand this, and that's why every major language has a very robust and very expansive packaging system, because these are things that are shared code that every application needs. That I don't need to rewrite. I can go download a package and implement it into my code. And so that's where the context versus code comes in. And the same study shows that about 50% of that time in the development lifecycle is done on context, right? Building a CI/CD pipeline every time. And I know that a lot of you might be thinking, well, we share a pipeline, but not a lot of people do, apparently. Every team tends to go and create their own pipeline. Every team tends to go create their own environment. They try to create their own automation. There's a lot of time that's wasted. And 50% of your time means that you can either double your throughput, right, or reduce your stress by 50%. So there's absolutely value in doing that. And that's why DevOps really helps in that aspect. So here's an example of some things that DevOps can provide and helps you reduce that core versus context ratio, right? Things like compiling code, right? That is something that is consistent and standard. You're not going to build your own compiler anyway, so use one that's out there and build the workflow around it. Building infrastructure, standardizing your packaging, standardizing your security, scanning, and certification. This is very, very significant for any company that wants compliance, or any product that needs to be out there in the industries that have that kind of security aspects. And in today's world, really, that's every industry, right? The world has become dangerous online, in between the hacking attempts and uh, the ransomware and all those other things. You need to make sure that you have very proper security scanning and certification. That could be costly. Next is standardizing deployments. How do you standardize deployments across the board so that you don't have to reinvent it every time? And then your normal, your usual suspects, your monitoring, your networking, your scaling, and your alerting. These are all things that DevOps can help with. And in my mind, GitOps is exactly how you implement this and you apply it across the board. Well, what is GitOps, right? GitOps is a method to implement DevOps. It basically came out of the infrastructure as code movement, where all your code represented your infrastructure, and there were systems that read it and built that infrastructure for you. And the change mechanism is done through a pull request. What that means is there's a submission to change something through a pull request. Somebody looks at it, and then when it's accepted, it merges it in. And the tagging maintains the known state of the system. So you tag with a version or a date or a branch name, environment name, and this is how you know what the state of that system is. And ultimately, it drives CI/CD, continuous integration, continuous deployment, and uses the repo as your state store. Right? Rather than having to provision disk somewhere or somewhere in the cloud, your actual Git repository is your state store that CI/CD can listen to, push to, read from, do what it needs to do to implement that DevOps model. So if you go back and think about the infinity symbol, we're trying to plan, build, integrate, deploy, operate, and get feedback. And GitOps gives you a solution for all of those. It lets you store the data. You can plan in GitOps through an issue tracking system. You can submit the code and build it and do everything through CI/CD off of that. When it's done, you put the final state of what you want to deploy in there. Something picks it up and deploys it to the infrastructure. And then it comes back through the feedback, and that could potentially be a bug or some other mechanism in Git that you feed it in, and then you go back into your cycle. So let's dive in a little bit more on how GitOps can actually be implemented. Well, the first question, whenever you have to answer a how question, is, do you build or do you buy? Do we go buy something that's already out there? Do we build it from scratch and do it our own way? Well, I don't think this is really an important question to answer, because you're always going to extend and integrate. So whether you build or buy, plan that you are going to extend whatever product that you have, and you have to integrate it into all the other instances that you want to use. There is nothing that you're going to be able to buy that is 100%. And there is nothing that you're going to be able to build that'll get you to 100% before it's too late. You can build something from scratch, and you'll probably get it to a point where it satisfies your needs, but then you're going to need to extend it and integrate it eventually, and then that's just a continuous cycle. So there is a little bit of commitment there if you're going to build, but even if you buy something, you're still going to extend it and integrate. So make that choice based on how far a product is for you and what it is you want to do and with the extension and the integration. So let's take a look at what we just mentioned on some of the things that we are going to use GitOps for our DevOps. And let's see what, for example, open source software already exists for that. So I've put, a couple of these things, a couple of these products out here that either I've used in the past, I'm using now, or I'm planning on using. And let's jump into each of those here and see what questions you should ask and how you should tackle it. So let's look at compiling code. there's a CNCF project called Cloud Native Build Packs. This is a really interesting project that came from Heroku and Pivotal. And if you think about what they originally offered in their products, where you just give me your code and I'll figure out what it is and I'll build it for you and create a standardized package and run it on my infrastructure. And so Heroku had the Heroku Cloud where you can run something seamlessly. Pivotal was using Pivotal Cloud Foundry and was able to build it and run it as an application for them. So that's great. Let's use that. Well, what are some of the problems that you're going to face when you are deciding to choose an open source product that does your code compilation? Well, first of all, whose build packs are you going to use? Today, there's Google. They offer their build packs. There's Paketo. They offer their build packs, and a couple of others out there that you can pick and choose from. So you're going to look at the pros and cons and what languages that they support and what languages that you're going to be using and pick one of them. But what about testing requirements? They don't necessarily have in their build any kind of make sure that you have certain code coverage requirements or any kind of license monitoring requirements. And that's something that, we had a requirement for. So that is where we now have to go and extend the vendor build pack. So we're going to pick one and we're going to extend it, but we're going to add testing, right? We're going to make testing part of the build. If your tests fail, then your build fails. And we're going to start defining company golden images. Just because, Paketo or Google or whoever have certain images doesn't necessarily mean that works for us. We're going to define our own golden images and extend it and replace maybe what the vendor has. And the way we're going to tie that into Git is we're going to host those definitions, they're TOML files, and we're going to put them in a Git repo and have a process that continuously integrates and builds the changes and deploys them out to our registry. So now we can seamlessly update the build pipelines for all of our code managed by a central repository. If something goes wrong, I can roll back and get back to the latest the functioning version without having to go and do a very big, wide scale, process with all the developers to have to go click something. So that's how we're tackling, for example, the code compilation build pack issue. What about infrastructure? How do we build infrastructure, right? And many of you have used Terraform before. There's Pulumi, and there's Crossplane. Those are all CNCF projects. But let's take a look at Crossplane, for example. That's a really nice, container-based, Kubernetes-based infrastructure tool that has the benefits of a reconcile loop. And the great thing about a reconcile loop is you can always guarantee that your infrastructure will be at this well-known state. And you submit the CRD to Crossplane, and if somebody goes and messes with that infrastructure in the cloud provider, it'll immediately bring it back. So that was really nice. That's one of the reasons that Crossplane looks like a great option for a lot of people in that aspect. But here are some problems that you might face. Many companies have strict policies for their cloud infrastructure. Just because you have a tool that can build any kind of infrastructure out there, that doesn't mean that it's going to be allowed. And it also means that it may be restricted to certain regions and services. Maybe you want to deploy certain things in the US and others in Europe, and those things can't talk to each other, or they can't have data moving from one place to another, whether it's GDPR or any other kind of restriction. Also, cost control, right? We may not want anyone to go ahead and create a 64 core machine learning specified VM just to deploy a website. All right, there may be some controls that we want to put in there and restrictions so that we can manage our costs. So, well, how do we do that? Well, actually, Crossplane is very much GitOps oriented, and they have a way for us to extend a composite resource definition. And what that is it's a custom resource definition, but it allows us to kind of stitch together multiple of their own CRDs into our own composite. And that composite can be as simple as create a database. And that'll then turn around and say, that means I need VMs, I need this type of database, I need this much storage, I need this much networking, et cetera, et cetera. And we can really simplify it down to satisfy our policies and satisfy our restrictions. And then from a GitOps perspective, we put these definitions in a Git repo, and we tie the cluster and the tool to that repo so that if we need to change it, if I need to change that database composite resource to also include a number of replicas object, then I can easily add that in there, make the commit, and now it gets propagated to all my infrastructure. So that's how I can, again, keep a standardized contract in Git, but still apply it across the board. And so that's an example of using it with Crosspoint. What about security scanning and certification? I talked a little bit about how this is becoming a hot topic. It's starting to become an issue. And there are a lot of tools in CNCF that offer this, that are free for everyone to use. They're open source. You know, Falco and Kyverno. Those are a couple of tools that you can use for you to be able to do scanning and certification. But the problem is, well, you know, not all policies are ones that our security team finds necessary. And in other cases, we may have other policies that don't come out of the box with this. Well, so how do we do that? Well, again, we host our definitions in a repo. And we have our security experts define what those are, put them in the repository, and then whenever those get merged into a branch, they get propagated up to this to Kyverno or Falco. We then take the existing policies and modify them, or we create new ones. And ultimately, we now have a single source of truth for all of our policies in a Git repo that we can look back and compare between releases and see what, you know, controls that we have globally. And that is, you know, given to us through implementing the Git repo. So this is really, from a feedback perspective, it really closes that loop. So think about it this way. Think about if you want to deploy something that goes against the policy, it'll immediately come back and say, nope, you can't deploy it. And so that loop just comes back again into the planning phase. But better yet, because this information is in a Git repo, teams in their this in the continuous integration phase. So they don't even get to the right side. And this is where shifting left comes in, right? We've shifted all of this through using GitOps closer to the left so that we can stop it either in the integration phase, or better yet, the developer can look at that same repo and make sure that their code doesn't violate any of the policies. So that's another way that you can use GitOps to your benefits. What about standardized deployments, right? How do I get everybody to be able to deploy in the same way so that it's easy for us to extend and manage? You know, and Helm is one of the main tools that people have used, for example, in Kubernetes to deploy. But once a Helm package is cut, it's cut, right? And let's say, for example, a couple of releases ago, their ingress object got promoted from beta 2 to full release, and a lot of things broke. How do you fix that when you have these older Helm charts out there? Well, you got to get the Helm charts updated. You got to coordinate everybody to go through and do a Helm upgrade so that they can change their object. But you know, there are tools out there. There's open source tools like Kubevela that implement the open application manifest and make it a lot easier for that to be abstracted out, and then you can deploy whatever version of ingress that you'd like. But what are some of the problems that you might face? Well, deployments are hard, right? I mean, they're really complicated. They can get very hairy and complicated for different application types, especially if your company has a lot of interesting requirements around multi-regional deployments or progressive rollouts or so on. You also have strict policies or features that are requirements based on your industry or your release, right? Maybe you don't want to allow any ingress that doesn't have SSL, right? Or maybe you are allowing you have very strict resource limits in place, or maybe you want to have very strict pod disruption policies. whatever it is that you have, these are things that might come from your architecture, your security team that you need to implement. And so that's a problem. Kubevela is not going to do that for you out of the box. So how do you do that? Well, again, you'll see this comment in all of these solutions. You host the definitions in a repo, right? The great thing about the way that OEM is structured and how Kubevela implements it is there's a concept of a trait. And so you define your base implementation, then you add traits underneath. And you can add those traits as you see fit. So you host the definition of the trait in the repo, and now you have a seamless global update. In the example of the ingress, we have an ingress with a particular API version. When that needs to be updated for the underlying version of Kubernetes, you can change that repo, submit a pull request, it gets merged. Every ingress after that will be on the new version, and the developers don't have to change at all. We can also modify existing ones, like in that same the ingress example. It's called a gateway trait. We have requirements where we must have TLS on all of all of our ingress, and so we then take that and modify it and add the annotation so that we can do that. So the developer doesn't know the difference; they're just getting an HTTPS endpoint instead of an HTTP one. Other things you can do is you can create new traits, whether that is for a tool like, let's say, Dapper. If you want to create a Dapper integration, you can create a Dapper trait, which simplifies annotating, your deployment or creating custom configuration or CRDs. And it's as simple as the developer adding, I would like to use Dapper, or I would like to use this database migration tool, or whatever traits that you want to add. And again, you put those into your Git repo, you bind your clusters to that Git repo, and you can seamlessly deploy across the board. Monitoring and alerting, right? That's usual suspects, usual problems. In a lot of cases, there's a lot of third-party tools out there that you can pay a lot of money for. But let's take an example of an open source project. Let's look at the Grafana stack. That's a great tool. It works pretty well out of the box, but like every other tool out there, it doesn't have all of the dashboards, alerts, and channel management built out of the box for you. You're going to have to do it. But then you also have retention rules. In some cases, a day is fine, and others 3 days is fine. Others it needs 10 days. You also have data isolation, compliance, filters, all of this and that. So you will need to go and potentially modify the configurations, or in some cases, you need to modify the behavior altogether of the stack. So what's the solution? Well, many people have solved this particular one before, and they've built custom operators to manage these resources, where you can take effectively an abstraction and have that abstraction execute some code that configures the stack. So you can find one and deploy it, or you can build one yourself if you need to. We can also segment the platform according to business and automate the deployment. So if we wanted to say, for example, we want all of this type of business over here, or that type of business over there, we can do that and automate the deployment between namespaces or clusters. And then we just put all of that bind it to a Git repository, so that all of these CRDs or all of these configurations are consistent, and all of the clusters get pulled in and managed at the same time. Getting close, I promise. Networking, right? Oh man, it's always DNS. There's always a problem with networking, cert management, route management. It's always going to be very particular on whether you need to do whitelisting, you need to do CIDR overlapping, you need to do, there's a whole bunch of stuff. And there's a lot of tools out in CNCF, many, many tools out there. Calico, Submariner, so on, that all try to solve this problem one way or the other. As a matter of fact, if you do now go to my GitHub, there is that example of how you can build a scupper operator, which is a virtual application network between multiple clusters. And it's a way to basically create a seamless virtual application network between clusters, regardless of where they are. You can have a cluster on your laptop and another in a cloud, and you can connect them seamlessly. So do go and check that out if you're curious. But a solution to solve it is to do what I did, which is build an operator to automate CLI and API calls. Right? A lot of these things come with either a UI for you to click around and do stuff, or they come with a CLI, which is intended to automate a lot of this stuff. But you can't do that at scale. So build an operator to do those for you, which is basically, it could be as simple as some CLI script that's wrapped in a container exposed as an operator, or it could be higher level code. In my example, I actually wrote it in C#. Also, another thing that I tend to do and encourage people to do is define a company compliant abstraction, right? Try to create a CRD, right? A custom resource definition that really abstracts the concept but makes it simple. Start with the simplest thing you can and then increment after that. Don't try to do everything. If we want to do, for example, networking point A to point B, just define point A and point B. That's all you got to do. If then you can talk about how kind of security, what kind of retry, latency rules, all that stuff can come later. Just start with a simple abstraction. Once you get there and test it, then you can add to it. So that's another thing that you can do. And then obviously bind your clusters to the repository, right? Every cluster can wake up and point to that same repo. You make the change and deploy it. It automatically gets pushed out to all the clusters. So, as I've been saying, you probably noticed a lot of the patterns in there. I'm a big fan of open source software. Go ahead and pick the ones that you feel are right and extend them, and always try to tie your systems to a repository. Have them come in and pull from your repository so you don't have to worry about all the connectivity out to the different clusters. The cluster itself or your infrastructure itself can actually be, in some cases, firewalled off from everything else except for that repo, and you'll still be able to seamlessly manage hundreds and thousands of your clusters or infrastructure, however you want. So to recap, always assume your system's going to disappear and you need to create them at any stage, right? When you put that kind of requirement in mind, that means that everything that happens into your system should be defined in a Git repository. Because if that dies or gets deleted, you should be able to point to that repo from some other system and be able to recreate it at that point. And then if you're going to have to do something manually, then write code to do it, right? Don't ever assume you have to get a system up to a certain point, then you go do something manually, then you continue the automation. Everything you can do manually, you should be able to write code to do it. And then treat your repository as your state store, right? This is your golden image of what your system looks like. So protect your branches, tag your branches, treat it as if it were code, right? Add the reviewers in there, add integration testing in there, do everything you need to do, because once it gets into that branch that your infrastructure is tied to, it will become that state. And so always protect it and make sure that you consider it as your golden image. Another thing is always abstract the complexity. And it's okay to be opinionated, right? Don't try to be everything for everybody. There's a saying back in the, I think it was Ford that mentioned, if I ask the customer what they want a better horse, right? Elon Musk does this a lot. Apple does this a lot. It's okay to be opinionated. If you're wrong, they will tell you you're wrong and you can fix it, right? Because we're following DevOps in general and we're reducing that cycle, it's fine to be wrong. You've only missed out on a small increment, and you can come back, take that feedback and fix it. But abstract it and be opinionated and build that first, and then take the feedback. You'll be surprised at how many more times you're right than you are wrong. And then, build or buy, but you should also always extend and integrate. That's always going to be something you have to do. So don't ever expect to find something that covers 100%, whether you're you're building it from scratch or you're buying it, even if you build it, there will always be continuous requirements that come in. And so expect to extend and integrate anything you use. And then finally, if you use an open source project, uh, please contribute back, right? This is how projects continue to stay healthy and alive, right? It's not necessarily contributing back in code, contribute back with a star, contribute back with documentation, contribute back with requesting features or issues. So, contribute money to the projects. Um, even that will make sure that the project knows that there's people using it. It'll continue to keep it healthy. The more that you are active in that community, the better this product's going to be, and the better all of our lives are going to be. Because remember, your software ROI starts at production, so the more that you can reuse, the better. And 50% of our life cycle is on context, and that's where these projects come in. So, a healthy project is great for your development life cycle. It's great for you. Uh, I feel good when I contribute back to open source because I use open source so much. It feels, uh, like I'm doing the right thing, and then ultimately, it's better for our industry as a whole. So, again, contribute back where you can. And all in all, hopefully, this has been a very useful 30 minutes of your time. I talked a little bit about DevOps and how we can use GitOps to get that achieved. And hopefully, um, there's something that many of you have taken from this. Please do reach out to me, give me your feedback, and I look forward to hearing from all of you. Thank you so much.